All right, so for adding and subtracting matrices, we said they had to have the same dimensions, right? For multiplying matrices, you also have to check the dimensions, but it's a little bit different. To multiply a matrix A by a matrix B, the number of columns of A, why doesn't it select? The number of columns of A has to be equal to the number of rows of B, okay? Then the product will have, the dimensions of the other numbers. Okay, what does all that mean? So you have to multiply matrix A times matrix B. Matrix A has dimensions 3 by 2. B has dimensions 2 by 4. You write out the dimensions, okay? If these inside numbers are equal to each other, then you are allowed to multiply them. Then it's possible to multiply them. Then, once you do that, these outer numbers, 3 by 4, will give you the dimensions of the new matrix, okay? So, potentially, you have a 3 by 2, you have a 2 by 4. These are very different looking matrices, and then their product will be even different, right? Also different, potentially. Okay, so here is, sort of like some description of how to multiply them. And then I also have tried to do the same thing here. Honestly, you can say all the words that you want. Really, what you have to do is just see one done, and then that's how we're going to learn how to do it. Okay, so take a look at this for a minute. Okay, so I want to do, here I have matrix A and matrix B, and I want to find A times B, right? Okay, so first of all, what is the dimensions of A? It's 2 by 3, and this is 3 by 2. Okay, so they can be multiplied because the 3's are the same, and then the product is going to be a 2 by 2. Okay, so let's go ahead and write that down. AB is equal to this matrix times this matrix. Okay, now we just said the product is going to be a 2 by 2, right? It means I'm going to have a term here, like that, 2 by 2, right? I am going to spread it out a little bit, okay? Everybody agree this is a 2 by 2? Now, we are going to go ahead and we're going to populate this new product matrix. Okay, there are 4 spaces in here. We're going to go with the first one. What position is that? This is row 1, column 1, correct? So what I do is I go back to my matrices and I take my row 1 and my column 1. How many is in row 1 that I circled? How many is in column 1 that I circled? Okay, those numbers have to match up, right? That's how you know you picked the right configuration. Now, you have to match first with first, second with second, third with third, and multiply those. So look up here for a minute, okay? So you do first with first, multiply these two, multiply these two, multiply these two. That gives you 3 numbers. You add them with each other, okay? So negative 2 times 2 plus 0 times negative 1 plus 3 times 9. All right? Okay, then you take another one. All right? So now I want to do the one right next to it. So this is row 1, column 2. That means I take row 1 with column 2. And I do the same thing. Negative 2 times 0 plus 0 times 2 plus 3 times 3. Okay? Next, go down. I'm going to do this one, row 2, column 1. So I take row 2, column 1. Do you see how if you had these matrices in different order, you would not get the correct ones? So here I get 5 times 2 plus what? negative 7 times negative 1 plus 1 times 9. Okay, so do you have to write it out like this every single time? Of course not, but I'm going to do it one time so, you have a way to get back to it later. Okay, what's the next one? Row 2, column 2. Now, you don't have to go in order. You can be a rebel and, go like in, like random order. It really doesn't matter. Just wherever you are, take those two sets. So row 2, column 2, 5 times 0 plus negative 7 times 2 plus 1 times 3, and that's it. Now, just do a little bit of math. For the first one, I get 23. The blue one gives me a 9. Green one, 26, and then negative 11. All right, and as promised, do you see how you multiply this matrix times this matrix, and this is the product that you get, right? So for the first time, like in numbers, I multiply 3 times 5, multiply a number by another number, I get another number. All look very similar. But do you see how different this looks when you multiply it, right? Isn't that fun, right? So multiplication means a whole other thing. Okay, next we're going to do B times A. Okay, B times A, that means it's going to be this one, 2, negative 1, 9, 0, 2, 3, times the other matrix. And I really suggest writing these out because otherwise, you'll drive yourself crazy going back and forth, right? Okay, let's see. Dimensions first. This is a 3 by 2 and a 2 by 3. Is it possible to multiply? What'll be the product? A 3 by 3. So let's get ourselves a 3 by 3 here. It's going to be the outside numbers. So if these two are the same, okay, these two numbers on the outside will give you the dimensions. Did you see that? Okay, the middle ones have to be the same for you to be able to multiply them. Then the outer two give you the dimensions. Okay? All right. So this is going to be a 3 by 3. Okay, so let's go here. First one is row 1, column 1. Row 1, column 1. Oh my God, look, now I have 2 in each, right? They match up. Okay, so I'm going to get what? Negative 4 plus what? 0. Okay? Next one, row 1, column 2. 0 plus 0. And then row 1, column 3. What is it? 6 plus 0. So this is another one, right? If you're texting and TikToking at the same time as you're doing this, it just, gets messed up. Okay, let's go down a row. So let's do row 2, column 1. Row 2, column 1. Is everybody okay with how we're getting these random numbers? Okay, so what am I going to get here? What plus what? 2 plus 10. And then next one, I also like to do an arrow sometimes. It's easier. 0 minus 14. And then here, negative 3 plus 2. Is that right? Lastly, row 3, column 1. What is that? Negative 18 plus 15. Column 2, 0 minus 21. Column 3, 27 minus 3. Okay? No, plus 3, plus 3. Okay, so lastly, I get negative 4 going across 0, 6, 12, negative 14, negative 1, negative 3, negative 21, and 30.
Is it 2 plus 0 or 0 plus 0 for R1, C2? For row 1, column 2?
0 plus 0. Yeah. Okay, so, All right, so take a look. The first case, we got A times B. The second case, we got B times A. And for the first time ever in your lives, you are now encountering something where multiplication is not commutative, right? For the first time ever, I do 3 times 5 times 5 times 3. They're not the same, right? So A times B, B times A is not the same. So you've got to get that order right, all right? Questions? What sound is that? Is that the heater? Oh, no. It's a ghost. It's the math ghost. They're coming to see multiplication. Okay, let's take a look at this one. I love this one. It's so much fun. AB, right? So let's multiply A times B. Yeah, so this is a 1 by 3. And this is a 3 by 1. So I'm going to get a 1 by 1 when I'm done. Okay? So let's see. A times B. This is going to be negative 2, 1, 3. 4, that's an area code. 4, negative 6, 5. Okay, so I'm going to get a 1 by 1, right? That means I only have one term in my matrix, a 1 by 1. So all I have is row 1, column 1. So what do I get? Negative 8, negative 6, positive 15. It's a 1. But that's not the number 1. That's a matrix with an element of 1. Completely different, right? I can't take that 1 and add it to another 1 because 1 is a matrix, 1 is a number. They're completely different beings, okay? But isn't that cool? You just get that. Okay, so now let's do B times A. Now I'm going to get 4, negative 6, 5, negative 2, 1, 3. This time, it's a 3 by 1 and a 1 by 3. What am I going to get? A 3 by 3. Okay, but look at how cool this is. Row 1, column 1, it's just one number in each. So this is just negative 8. So what's the one next to it? 4 and then 12. So going to the bottom, the second row. Fabulous. Negative 10, 5, 15. I feel like that's a sleigh, right? Right? Okay. Okay. All right. So what properties are the same? Obviously, commutative property of multiplication does not work, but associative works. So if you have to multiply 3 matrices, as long as you keep them in the same order, it doesn't matter if you do A, B times C or, the other order. Scalar multiplication works and so on. Okay, now, once we're done with matrix multiplication, let's talk about inverses and determinants, right? Okay, we've talked about functions having inverses, right? And if you have f of x and f inverse of x, there is a way to verify them, right? They have a relationship. F of g of x has to equal what if they're inverses? X, right? So there is that. This inverse that we're talking about here is a similar analogous situation, all right? Okay, a determinant is a scalar. It's just a good old number, negative 4, 110. And it is unique to each matrix, right? And like in linear algebra, it could have all sorts of meanings and, value and all that stuff. So we're first going to talk about how to find a determinant. Finding a determinant for a 2 by 2 matrix versus a 3 by 3 matrix has a different process. So before we start looking at how to find a determinant, let's talk about notation. So suppose you have matrix A and it's written, like this. A, B, C, D are the entries. Determinant of A can be written as this. That's one notation. Or, okay, A in vertical bars. This is not absolute value of A. When you see that in the matrix world, it's determinant of A. look, at some point we have to like reuse symbols, right? We can't just come up with new symbols for each world, so we're just recycling them. Or you can put the whole thing in vertical bars and say determinant of this matrix. Okay, that's notation. So now, if you have a 2 by 2, how do you find the good old determinant? Okay, here you go. Super straightforward. Remember that main diagonal? It never leaves. So it's A times D. You multiply everything on the main diagonal minus the other diagonal, B times C. Always a minus, always in that order. Main diagonal always comes first. Okay, that's it. Okay, and a little bit of a Jeopardy trivia for you. If you're ever on Jeopardy and this comes up, don't forget, on-air credit for me. A matrix which has a determinant of 0 is called a singular matrix. Okay, so let's find the determinant here. So determinant of A, straightforward, 1 times 3 minus negative 8, 11. That's it. That's it. Okay? This is like the easiest thing you'll do in this class. Okay? Okay, so let's talk about inverses. Okay. This term, the multiplicative inverse of a number A is 1 over A. So for example, if I have the number 3, the multiplicative inverse is 1 over 3. Basically, it's the number that you can multiply 3 by to get a 1. All right? So the multiplicative inverse of a square matrix is the inverse matrix. Okay. Now, the notation for the inverse matrix, why can't I highlight? Is A to the negative 1, just like you're used to, right? Okay, so how do you find the inverse of a 2 by 2 matrix? The inverse is 1 over the determinant, that number that we just found, times a rearranged matrix. So what's the rearranged matrix? Look at this. The main diagonal, they just switch seats, right? They just swap. And then the second diagonal stays the same, but you add negatives in front. Okay? You change the sign. Okay. So a singular matrix, obviously if the determinant is 0, then you can't do 1 over 0. That means a singular matrix has no determinant. I'm sorry, it has no inverse. Okay, so let's find the determinant here. Okay. Find the determinant and then the inverse. So what's the determinant here? 40 minus 40, 0. So no inverse. All right, here. The determinant of A is negative 12 minus negative 16. So that's a 4. That works. Okay, so what's the inverse then? A inverse is 1 over 4. Okay, the main diagonal has to switch seats. So 6 and negative 2. Oh, it's unfortunate that I picked the same numbers here. The other ones, they stay where they are. You just change their signs. So negative 4 and 4, right? It's unfortunate that I put both 4s. But if this was like 5 and negative 4, it would just be negative 5 and positive 4. Then you obviously have to multiply this in. So A inverse is 6 over 4, negative 4 over 4. But, I mean, it's just embarrassing to not simplify your fractions. So let's go ahead and simplify those fractions. And that's it. So simple, right? That's the inverse. Okay? Okay, so if you have a number 5 and you multiply it by its multiplicative inverse, what do you get? 1. So if you have a matrix and you multiply it by its multiplicative inverse, you should get what's analogous to 1 in the matrix world. That matrix that's analogous to 1 in the matrix world is the identity matrix. All right? So the identity matrix is a square matrix such that A times the inverse is A. Okay? So this is important. If A is an n by n matrix and B, okay, there's a matrix B. If A times B and B times A equals the identity matrix, then B is the inverse, right? Which means if you have two matrices, they're inverses of each other. If you multiply them by each other, you get I, the identity matrix, okay? To verify that A and B are inverse matrices, check if AB equals I and BA equals I. Okay, so for this one, let's do A times B. Okay, so what result am I going to get? What by what? A 2 by 2. So first one, first row, first column, what do I get? 1. First row, second column, 25. What do we get? Is it negative 11? Okay, so this and this, right? So first with this, negative 30, positive 30, 0. Okay, let's do it again. Let's do the bottom ones. Let's do this one and this one. I do get 0. And then these two, so I get negative 24 plus 25, 1. Okay, what matrix is that? It is row echelon form, but this specifically is the identity matrix because the first column is 1, the rest are all zeros. That's the identity matrix. Yeah. I'm sorry, the first diagonal is 1. So, so this is row 2, column 2, right? This is the position, row 2, column 2 in this matrix, right? Is that, everybody agree with that? Well, row 1, row 2. So this is row 2. Column 1, column 2. This is column 2. So this is row 2, column 2. So when you go here, you take row 2, column 2. 2 items in here, 2 items in here. Now, you match the first with the first. Multiply these two that I'm pointing at. What do you get? Okay, negative 24. Plus multiply these two. What does that give you? Negative 24 plus 25? 1. 1. No, same way that we did it before. I promise. I haven't changed things on you.
We're just not writing it out.
Right, we're just not writing it out. We're doing it in our head. Okay, now, let's do the next situation. B times A. 5, negative 6, negative 4, 5. 5, 6, 4, 5. Okay, so first here, okay, this is row 1, column 1. The first two give you 25 minus 24, 1. This is a 4. Right? Okay, so look, go in here in the product, in the answer matrix. I'm going to fill in this space. What position is this? In this matrix, this is...
row 1 column, I don't get how did you multiply 5 by 5 and then
Okay, so now, okay, row 1, column 1. You take row 1, column 1. Same as this, row 1, column 1. First with first. These two go together, 25. These two go together, negative 24. So the first one's, okay? Okay, so next one here, we're going to get what? 0. Okay, bottom row, what do we get? 0 and 1. What do we get? I. Okay, this is the only time where you can do matrix multiplication and it's commutative. The only time where you can do AB and BA, and if you get I for both of them, that means A and B are inverses. Okay? So if I ask you, verify that A and B are inverses, just like for the functions, you can't take A, find the inverse, and say, look, Miss Malikian, that's the same as B. No, that's finding the inverse and showing that it's the same as B. But when I use the word verify, we got to go, mathy, and we got to do the theorems. Okay? Yeah.
But if you say verify, there's like anything more which just kind of wrote out like this times this.
Right. Well, you have to show that A times B equals I, and you have to show B times A equals I, the identity matrix. Remember, it's always about the process and less about the final answer.
You know what I'm saying? Like we have to write out like 5 times 5.
No. Just write this out. B times A equals this, and then I just have to see that you did it for both cases, and yeah. Okay. So this was about a 2 by 2. We learned how to find the inverse of a 2 by 2. We learned how to find the determinant of a 2 by 2. How about a 3 by 3? A determinant and the inverse of a 3 by 3. This is like way more fun. Okay, again, words. You just have to do one to understand. So look, reproduce, basically clone the first and second columns to the right. So A, B, D, E, just rewrite them here. And then you have to draw diagonals like this and find their products. So now let's do this one. So first, clone the first 2 columns here. Have I done any math so far? No math. Now, we have to do arrows, all right? Okay, remember guys, it's always about that main diagonal. What's the main diagonal of this? This is the main diagonal. That's what you start with. So 1, 2, 3, okay? So here, what are we going to get? Okay, on this first diagonal, what do I have? 3 times negative 1 times 5. That's negative 15. Plus, what do I have on the other one? 4 plus 0. Is everybody okay with how I got these 3 numbers? Yes? Okay, now I have to do diagonals going the other way. I always start inside the matrix. So here, here, and here. So start within the matrix, go this way, this way, this way. Okay, now look. These ones going in the opposite direction, we have to subtract them. So I do minus, and then I go inside and multiply. I'm going to get 0. Minus, what, 12? 24. Minus negative 10. Okay? Okay. Oh my God. I have such horrible notation here. This is not equal to that. Oh my God. I would so take points off if somebody did that. Here, we're just going to write determinant. I'm just going to do this. Determinant of A equals that. Oh my God, Miss Malikian, I don't think I've ever done that in the however many years I've been alive. Okay. So determinant of A, if I multiply all this, if I add all this out, what do I get? Negative 25. So that is the determinant. Fun, right? I mean, not much, like, it's not too difficult. You just have to remember the process and that's it. The last lesson is more complicated. Like this, you could literally like take like an elementary school student, you can show them what to do, and they'll have no idea what they're doing, but at least they'll be able to do it. Yeah, there isn't much mathiness here. Okay, now what about the inverse of a 3 by 3? It turns out finding the inverse of a 3 by 3 by hand is just this nonsense, brutally just annoying process. So we're not going to do that by hand. We are going to do it. Okay, so here's what we have right now. We just looked at a 2 by 2 and a 3 by 3, right? We found the determinant and the inverse. And here we found the determinant. Okay, we still have to find the inverse. So all three of these in purple, you learned how to do by hand. This inverse of a 3 by 3 is the only thing we're going to do with the calculator. And you're never going to learn, I'm never going to teach you how to do it by hand, right? You can go learn it later on. But, I'm not forbidding you. Okay, so let's do this. Let's go ahead and take out the calculators. Fun stuff. Yes. Okay, I actually have steps on the back page. So here. So if you go into menu, right, from the home screen, go ahead and take out your calculator. If you go to the menu, we never noticed, but there is a matrix menu here. So let's press 7 and let's create a matrix first. Oops. Number 1, create. And what are we creating? A matrix. And yeah, let's do a 3 by 3. I do 3 tab 3 enter. Okay, there's the 3 by 3. Now go ahead and we're going to put the same one as we were working on in the previous page. So this one. Okay, so here's how I like to do these. To go between entries, press 3 tab. That's the best way to traverse this. 3, 1 tab, 0 tab, and so on. Okay. 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 Now we need to find the inverse of this. So using the right arrow button, exit out of this so that you're outside of the matrix. Now hit to the power of the caret button, -1. Hit enter. There's your inverse. I know.
Then we just write that.
You just write that.
Is that how we find? Could that be
A -1, A inverse. Okay. Okay, now we're going to do something else. Watch. Go to menu, 7 for matrix and vector. 3 says determinant. Let's do determinant. Huh? Well, no. So I do want to put a matrix. Okay, at this step, you can either create a new matrix or I actually want to insert this one. So what I want to do is I want to go up, up, press enter, but now I want to edit this -1 out, right? So edit the -1 out. And then press enter. There's the determinant. Matrix, menu, matrix, number 3 is determinant. Okay? So listen, I'm never going to, okay, I'm always going to ask you how to find the determinant of a 3 by 3 by hand. You have to know how to do it by hand. You have to know how to find determinant and inverse of a 2 by 2 by hand. But the inverse of a 3 by 3 with the calculator. But obviously, you know, you can do this. So let me show you guys something else. Go to menu. Go to 7. Okay. Let's look at number 4, row echelon form. Right? Yep. So now let's put a matrix in here. Menu, matrix and vector. I want to create a brand new 3 by 3 matrix. Row echelon form. Okay, so let's see. I'm just going to put random numbers in here. -1, 2, 4, -5, I don't know, 3, 1, 1, 2, 1. There it is in row echelon form. Okay? So, again, when I ask you to find the when I ask you to put the matrix in row echelon form on the test, it will be on the no calculator part, unfortunately. However, you know, this is the way that you can do it. And then, you know, you can explore with this. If you go here, if you do here, there is also reduced row echelon form. Right under row echelon form, there is reduced row echelon form. Oh, this is it turns into an identity matrix. How funny. Okay. Oh, all XYZ is 1. So like it basically solves everything for you. Okay, this is, okay, I randomly chose this and then X, Y, and Z turned out to be 1. Like this is like, I should have bought the lottery instead. Now I wasted like my 1 in a million chance on stupid matrices. Gosh. All right. Okay. That'll never happen. Seriously. You have any idea how many hours I spent